Hello, my students. I'm sorry to miss teaching you today, but I know Miss Bernard is going to do a great job, and I trust that y'all are going to behave well for her. I'm going to try to talk you through the 6-1 notes that you have in front of you, and I trust that you all have your books open to page 269, so you can be looking at the book language as well as the notes in front of you. We're going to start a new chapter, which is exciting. This is a really important chapter, and we're going to be doing a lot of work with ratios and rates. So I want you to be looking at the definition of ratios and rates. Ratio is on the top of page 269. It uses division to compare two quantities. We've been doing a lot of division. We did a lot of fractions last chapter, and we are going to use ratios to actually compare a numerator and a denominator. There is a big O in the word ratio on your notes. That's not a typo. It is to help you to remember that ratios, when we write them, have the same units in the numerator and the denominator, so actually the units canceled out. Remember when we talked about anything divided by itself, I think we even said yo mama divided by yo mama was 1 and canceled out. It's going to be the same way with units as we talk about ratios. So here's an example. You hear this on TV all the time. 5 dentists out of 6 dentists prefer Crest. We can write that as a ratio. 5 dentists is the numerator, 6 dentists is the denominator, and the dentists actually cancel because they are themselves divided by themselves, and they cancel out, and we can just say 5 out of 6. When we're talking about ratios, we can actually write them 3 distinct ways. You can see this in the middle of page 269, and I've written it here. You're going to have to excuse my writing on this video. I do not have a pen. I am writing with a mouse. It's very hard to do if you've never tried it, trying to write numbers and fractions and stuff with a mouse. It's complicated, so don't laugh at me. Anyway, these are the 3 ways that our 5 out of 6 can be written, with the normal fraction bar, with a colon, or with the actual English word 2. So when we write ratios, we should write them always in simplest form, just like we did fractions in the last chapter. So an example of this is 8 out of 12 students did their homework. I could say 8 students over 12 students, but the students would cancel, and we just end up with 8 over 12, but we would need to reduce that to 2 over 3. That's in simplest form. Okay, congratulations. We're done with page 1 of the notes. This link will be out there on my homework page so that you can watch it. If you need to watch it at home, you can go over it again. Hear me talk to you another time. Let's do another example. Writing 2 feet to 6 inches. Obviously, these are not the same units. If we're going to write them as a ratio, we need to convert the feet to inches. So we know there are 12 inches in a foot. I hope you know that. And we can write the 2 feet 24 inches over 10 inches, and then reduce it to 12 over 5. So that's kind of a short synopsis of ratios, and much of your homework tonight for the next class will be involved simplifying and writing ratios. But there's a special kind of ratio now that we need to talk to that's called a rate. And yes, it has a big E at the end of it, and I'll explain that in a minute as well. But like I said, they are a special kind of ratios. And they also, let's see where they are in your book. I'm looking in my book, trying to find them. And they are not in yellow, but they are in the middle of page 270. And it says a rate is a ratio of 2 quantities measured in different units. So a rate is a special kind of ratio. It's a ratio where your units don't go away because they're not the same. We have rates, and then we have unit rates. This word unit, this unit rate guy right here, he is really important. And we're going to be talking, a lot about unit rates, and their denominator is 1. So I'm going to show you some examples when we get down a little bit further of how unit rates work. But let me show you just some examples of plain rates. 24 people to 6 cars. If we were going to write that as a rate, we would write it 24 people 6 cars is the denominator. We cannot cross out the people in the cars because people are not cars. And we can talk about that rate as a unit rate when we make the denominator 1. So the question would become, if 24 people fit in 6 cars, how many people fit in 1 car? Here is our denominator of 1. And when we find that out, we can say our answer is 6 people per car. And that's where your big E comes in on our word rate up above, because this big E right here is to remind you that the E in rate you can think of relating to the word per. Unit rate with a denominator of 1. So let's move on and do a few examples like this. I'm going to ask you to get your calculators now. I'll have, hopefully you'll have one with you. If not, Miss Bernard can pause the video. But we're going to go on down to the next page, and I've done a couple of these already with my bad writing again. I'm going to show you another example. This is a food example. When you're in the grocery stores, you see this all the time. Here's an example of $3.45 will buy you 16 ounces of something. And the way you write it as a rate, money on top, the money goes in the numerator. $3.45 for 6 ounces. The dollar sign is your unit in the numerator. The ounces, the abbreviation for ounces, stays in the denominator because we can't cancel them out. Money is not ounces. So we would write that 345 over 6, and then we want to know how much for 1 ounce. And the way you find that out is divide. $3.45 divided by 6 gives you 23 cents for 1 ounce. Or we can write it 23 cents per ounce. And the 1 is kind of the ghostly 1 implied in there. You could say 23 cents per 1 ounce, but when you say per ounce, people know you mean a unit of 1. Oftentimes that's how we compare which is a better price when we're buying things, and we'll actually do that in an example in a few minutes. So I want you guys to find the unit rates of a few examples. I've done the first one for you. Believe me, it was painful, everything I had to write. If we have 60 songs in 5 hours, we would write that 60 songs. Please write your units. They are important. And 5 hours in the denominator. The question is, for the unit rate, how many songs in 1 hour? The unit is 5 here, but we want it to be 1 here. You divide. 5 goes into 60. I know this is one of those things you guys got out of bed knowing that 12 times 5 is 60, so you don't need a calculator for this one. 12 songs in 1 hour, or you could say it 12 songs per hour. That is the unit rate. So I've got, 3 more examples that I'd like you guys to work on your own. And I will have Miss Bernard just pause the video right now and give you a few minutes. Get your calculators. You can certainly use calculators on these and come up with the answers pretty quickly, but please write them as a rate and then write them as a per statement as well, just like we did on example number 1. All right, we'll move on now. Use equivalent rates. Tell whether these rates are equivalent. Remember that the word equivalent means equal. You want to know whether these rates are the same. How can we figure that out? Well, there is, let me see where this is in your textbook. I am looking. And I think what I want you to do is look at the top of 270. And there is an example comparing ratios. To compare 2 ratios, you write both ratios as fractions or decimals. If they're the same, they're equivalent. So let's look at 12 over 9 and 24 over 18. We can see that if we multiply 9 times 2, we get 18. If we multiply 12 times 2, we get 24. And you betcha, we'll just put a little happy face right by this guy. Yes, they are the same. because you could multiply both the numerator and denominator by 2 and get a fraction that is the same. Let's look at 14 over 4 and 21 over 8. Let you guys figure this out on your own and see what you think. If we rewrite it, let me see if I can do this on the fly. 14, this takes a while, over 4, whoops, got it, and 21 over 8, my 8's slipping. We know that we can multiply 4. We can multiply, let me get this pointer back, 4 times 2 and get 8, but 14 times 2 is not 21. So no, these are not equivalent rates or ratios. They are not equivalent. Okay, let's move on to the last page of the notes. And we're going to do one example here, and the last example we're going to save for when I get back. I want to show you how we're going to set up a problem that asks you to compare. And this is a peanut butter problem. So you're at a grocery store. You see the opportunity to buy 2 different sizes of peanut butter, and maybe Miss Bernard can talk to you for a few minutes about other reasons why we pick large and small volume. But if we're just going by money, the way to figure out which is the better deal is to find the per ounce or the unit rate. And actually, most grocery stores have this. If you look underneath an item when you go into a grocery store, it will show you the per unit rate, because most people can't do this on the fly. But I think you guys will be able to do this next time you go to the grocery store. So here's your choices: a 12-ounce jar of peanut butter for $3.49 or an 8-ounce jar for $2.95. To know which one is the better buy per ounce, you need to find the unit rates. So the question is, $3.49 for 12 ounces, how much for 1 ounce? You take your calculator, you divide $3.49 by 12, and you get approximately, that's what our little squiggly means, approximately 29 cents per one, the ghostly 1 ounce. The 8-ounce jar, put the money on top, the money's in the numerator, divide it by the 8 ounces that comes in that jar. Your per ounce rate is 37 cents per ounce. So you can see that our 12-ounce jar happens to be the winner. He's the big winner because he is cheaper per ounce. He is actually, and the question says, how much money per ounce do you save? If you go back and look at the question, it's asking us, which is the better buy? We answered that. The 12-ounce jar. How much money per ounce do you save? And you save 29, or 37 minus 29 is how many cents, children, per ounce do you save? So this is kind of the unit rate and rate in a nutshell. Like I said, we're going to skip number 8 and do a couple of those problems when I get back. But now I'd like you to get started on your homework. And again, if you've got questions on this or you'd like to fill it out, the video will be out there for you to see. And I can't wait to be back teaching you again, and we will go over any questions you might have then. Thanks, and you guys have a great day.